All right. Our brass just finished up with a cleaning session in this ultrasonic cleaner. We use the Hornady solution. And while this is new brass, I still want to do the cleaning so I could make sure to get that oil residue that might be present on the inside of those case mouths from when we turned these cases. I wanted to get any brass shavings or cuttings off of the inside from all the other work that we did on the primer pockets and so on. So this stuff is ready for sorting. I'm going to weigh each of these cases now. 170.7. As you see, our dining room table has become an enormous graph, if you want to call it that. Setting up all these cases. This is the x-axis of our graph, and I'll show you what we're going to do for the y-axis here in just a little bit. That's 100 brass cases of this Lapua 243 Winchester. Case weights range from 169.6 grains all the way up to 171.4 grains. Now the 171.4, all these things way out here, and on the opposite end we can call those statistical outliers. And we'll punch some of these numbers up into Excel and run some descriptive statistics on this data set. But what I want to point out is that this area here, from about 170.5, probably over here is where our mean is, and probably also where the median is, 170.6, 170.7. So we're going to treat this as a population of brass. This is all the Lapua brass that I have for the 243 Winchester, and it tells us quite a bit. Now, a lot of folks, when they sort brass, they kind of stop right here. This would become one set that they load and another one, and so on and so forth. But we're going to go a step further, because now what we know is that, let's say, we know this is 170.6 grains. All this brass here is that. And of course, our scale is accurate to 1/10 of a grain, or 1/70,000th of a pound. But what we don't know is the distribution of the brass. Where is it thick and where is it thin? Now we know, after turning the necks though, that the neck wall thickness is pretty darn uniform. In fact, all these cases where we have a nice polished, fresh looking brass, we know that this is 15,000ths of an inch, or 0.015 of an inch. So we know this is very consistent. But what we don't know is the case thick here, thin here, thick there, anything like this. So what we're going to do is we're going to do another test. That's going to become the y-axis on our little living graph here. And we're going to do a volume displacement test with a graduated cylinder. Probably the last time you saw a graduated cylinder was high school chemistry class. These are pretty easy to get. I got this one through Amazon.com. Works out just fine for a 243 Winchester. This is a 25 milliliter capacity with an accuracy plus or minus 0.2 of a milliliter. The graduations here, from, as again, 0 to 25 milliliters, are in half milliliter graduations. Now actually what we're measuring is case displacement, not case capacity. I know throughout this video I've accidentally said case capacity, but it's really case displacement. So a case that displaces more means that the internal volume of the case itself is smaller. A case that displaces less has a larger internal case volume or case capacity. So if we think about it, what we know now is that the exterior dimensions of the case is pretty much the same. We used a full-length resizing die, remember, on our very first case sizing. We know that the necks have the same exterior dimensions, same thickness. We have a lot of consistency built into the primer pockets. But what we don't know anything about is that internal volume of those cases themselves. We know that they have a difference in weight. There's some variations in weight. Some of that can be explained by the actual makeup of the brass itself. In other cases, and even more likely, it's going to be some thicknesses or thinness differences on the interior or inside of those cases. So we're trying to ensure a very uniform size or volume of the expansion chamber. Well, that's what I'm calling it. And it's the volume of the case's interior. As the powder charge burns, we wanted to pressurize this case in a very uniform and consistent fashion. The only way we can do that is to make sure that the size of the case on the inside, the interior volume, what I'm calling the expansion chamber, to ensure that that is exactly the same size as much as possible. And that's the best we can possibly do to ensure that as this bullet leaves the case and the second leaves the case mouth, that they leave at the exact same pressure point, at the exact same velocity on the end of the muzzle. Now in the past I have left spent primers in these cases, filled them up with alcohol and filled them up with water, and then you dump it out and you weigh that. There's a lot of inconsistency to doing that, and it's very, very time consuming, and it really doesn't give you the answers that we're looking for. The reason why there's problems with that is as you fill it up, there's going to form a meniscus on the top of this case mouth, the meniscus of the water itself. Now some folks add a little drop of detergent to that water and that reduces it. And sometimes you actually, though, you have a bubble on the top of the case and you sit there forever trying to eliminate that. And then you dump it out and you weigh that you weigh the mass of that water or alcohol or whatever that liquid was. But you know, you're never sure you got it all. There might be another drop left in that. Maybe there was one drop left in this one and nothing left in the other one. So what I found to be a better way of estimating the volume of these cases is strictly by displacement. Using the graduated cylinder, put some water in this, drop this thing in, kind of on an angle like that, and watch how much has been displaced. That tells us an awful lot about the interior dimensions of this case, because we've already ensured that the exterior dimensions are very uniform. Okay, now we don't have to do the volume displacement test on every one of the pieces of brass. For instance, way down here we have one sample at 169.6 grains. There's no way that we can further differentiate this one sample at this very light weight. So I'm going to look at grouping some of these into a batch of brass that's just not going to make it into my precision rifle loads. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. I'm going to grab these 10 and pull those out of my running, if you want to call it that, for high precision rifle rounds. Similarly, on the other end of our sampling, I'm going to take 10 rounds off this side. This works out nicely because, you know, a box of ammo is 20 rounds. Now the rest, these 80, we're going to go ahead and do the volume displacement tests on. Right, so I completed the volume displacement test on the remaining 80 cases here after we moved 20 of those outliers out of the sorting, and they grouped up fairly well. We have a total range of from 2 milliliter case capacity all the way up to 4 milliliter case capacity, with 3 milliliter case capacity being the by far the most common. So what we're going to do is we're going to consider some of these smaller ones, if you want to call it that, outliers, and we're going to do some sorting out this way and consider those outliers as well. But we're not going to throw them into the same batch of outliers, because this should be a more consistent set. So it's a notch above those original outliers that we pulled out, those 20. So I'm going to move these 4 out of the way. And then we're going to deal with these here. We have 3 here. There's 16 cases, and I think what I'm going to do is consider those a different batch of outliers, keep them separate, load them together, and it won't be my high precision cases, but nonetheless I will, I think, group those together. I'm a little bit hesitant to group these in, but I think I can group all those together and maybe have to leave those separate. But the real focus is what to do with all of these. So we're going to start grouping these by the weight and that volume. Now these all have 3 milliliter case capacities. What I did under each grouping, from 170.3 all the way through 171.1 grains of the weight of the case, I looked at each of those groupings and specifically looked very, very closely at that neck turning. And if the neck turning was very uniform, nice fresh looking brass all around the case mouth, I placed it on the A plus side of this little line. If it wasn't a perfect case turning and we had some areas where this area here is below 15 thousandths, so a little bit inconsistent, I'm placing it to the right, call it an A minus grade. So we have A plus over here, A minus at this weight, and you get the idea, A plus and A minus at that weight, and so on and so forth. So I'm going to keep them grouped together now. So I'm going to take these 4 A plus cases, 5, 6, 7. All right, our sorting is done. We have some grade A plus at the 3 milliliter case capacity. Very tight tolerances on the weight of those cases, and we know that every one of those necks is very consistently turned. That gets it the grade A plus. Here's another one, a little bit heavier brass. Again, we have the same case capacity, and I've split them by the weight of the case. And also remember, my A minus designates that the case necks weren't turned perfectly well as I could do, but we've got some low spots in there that gives it the A minus grade. Then I've got a couple bags of grade B. This one here has a 2 milliliter case capacity, a little bit smaller case capacity than all the others in this population, and another grade B set of cases with a larger than normal or average case capacity. So they get the grade B there. I didn't further separate these on the results of the neck turning. And then lastly, we have a grade C. That was our outliers, the 20 cases we pulled out after the initial case weighing. Now we're going to keep these things separate throughout their whole life and put them in boxes and keep these things segregated and fired within these same groups. Our case sorting, and in fact all the case preparation, is now finished. I've been keeping some of the factory boxes from my 243 Winchester, and so I've reused those. We have our grade C down here, and that was our initial 20 case weight outliers, those that were a little bit lighter and a little bit heavier than the average or the mean. And then we have our grade B, right here. I bought these MTM case guard boxes for these rounds. And here we have our A minus, what I'm calling A minus. This is, if you look at it, the brass itself varies only 3/10 of a grain. And this is 3 milliliter displacement on the case volumes. And remember, this is the case necks that weren't absolutely uniform. Similarly, A minus is here. A little bit heavier case, same volumetric displacement. Then we have our A pluses. These are our top of the line. Really nothing wrong at all with these. The only differentiation between these two different A minuses, between these different A pluses is that one is a little bit heavier brass case and the other is a little bit lighter. Thanks for watching this episode of Extreme Reloading. Stay tuned. Next time, we're going to actually start loading.